Yeah, hello. We'll try to see binary search and its implementations. So the implementations are in two ways. One is iterative mechanism, one is a recursive approach. First, we'll try to see the easiest mechanism, that is iterative approach. The next we'll go for a recursive representation. So here I was already taken some kind of array which consists 13 elements. So I was also represented some kind of index positions from 0 to 13. So now we'll try to see that code to trace out what exactly it is happening. See, there is a main method. After this main method, I was created some kind of variables I, low, high, mid, n, key, and array of 100. So we are searching for an element. The searching element is represented as key, and we are going to do one thing, and we are going to trace the middle position from the given array. To trace this, we had a value called low. So this indicates the starting position of your array, and high is going to indicate the highest index position of your array. So low plus high. So by using this low and high, we are going to find the mid value. So the mid value is nothing but low plus high by 2. So definitely it is giving the middle index positions. By using that, we are going to trace your element. So either it is falling to left side or it is falling to right side. So I was created an array, and that is consisting a key. There is nothing but searching element, and n is nothing but a number of elements are going to be inserted into your array. Mid value, so we are tracing that middle index position, and a low and high. So low high is nothing but the starting index and last index. After this, we are having a printf statement which is doing some request to enter your elements. So I'm going to element some kind of 14 elements into my array. So it will be started from 0 and 13. So total 13 members are there. So after this, I'm going to use some kind of for loop which is used to do some kind of iterative mechanism to accept your values. I will be started at 0, and next we are going to accept the value. So 1 will be represented in the index position 1, and next we are going to request for next element. Like this, I am going to request up to 14 elements. After this, your for loop will be executed then, and we are going to have a statement called printf. So this is the representation which is requesting to give some kind of searching element. So I'm going to search an element called 2, right? So I'm going to search for an element called 2. So now what should I do? So before going to start this, at least I need to find that whether how many elements are there, whether it is having only one element or we are having 0 elements. So that we need to trace out. So for this, there is one condition I'm going to represent: low less than or equals to high. So if it is equivalent also, that is fine for us for comparison. If you are having high value is less than your low, so the searching will not be happen. So this is the strategy we are going to apply. Next, so what we need to do, first step, if your array is consisting an element that is follows low value and as well as high value, then I'm going to find the mid value. So I'm writing mid equals to, I'm finding a mid value, that is low plus high, 0 plus 13 by 2. So it is going to be 6.5. So this is the representation we have. So I'm going to make this value to float. Why? Because index positions are represented with integer values. So 6. So this is going to be my middle index position. So now my mid value is what? 6. So what should I do now? Whether I need to search for the left side or I need to search the right side. So that I need to find. So to find this, the next statement is saying that first I need to do the comparison of a of mid. A of mid, my array is this, the mid value. So mid value is equivalent to my searching element. So now I want to give my searching element as 2. So whether it is equivalent to 2, if the condition is true or false, we need to check. So obviously condition is false. So we need to look for the next statement. So that statement is saying that array mid of less than key. So I'm going to look for next condition, a of mid, whether this value is less than here 2. So a of mid value is what? 7. 7 less than 2. Is that condition is true? False. So what it is saying that 7 is not smaller than your 2. That is the representation. It means what? 2 is smaller than 7. There is only simple representation. 7 less than 2. So this condition will be false, right? It means what? 2 is smaller than 7. So 2 is smaller than 7 means what? We need to look for here 0 to mid minus 1. So in the next statement what we are going to do? We are going to do your high value will be mid minus 1. So why we are doing this? My low value is as it is, but I need to search for only this part. So for this what I need to do, high, whatever I'm having high, that is equal to mid minus 1. So if I'm going to do this, what will happen? My consideration will be from low to high. So that is the representation I had. So we'll try to see that. After this what will have? So your loop is iterating. So again we are going to check your low and high. Low value is 0 as per the considerations, and high value is what? Mid minus 1. So mid value is 6. 6 minus 1 means 5. So high value will be 5. So my consideration will be happened up to this part. 1, 2, 3, 4, 5. So my element, whatever it is there, it is going to be represented in this subarray. I don't want to do any kind of comparisons for 7, 8, 9, 10 and other numbers. So only half of the elements will be considered for next iteration. So if I am going to find the mid value is going to say that your low is 0 and this position is treated as high. So it is going to be 6. So this is going to be 5. So 0 plus 5 by 2. So it will become 2.5. So it means what? We are going to floor your value because it is integer index position. So 2. So 2 means what? 0, 1, 2. So this is your index position. This is going to be your index position. So now I am going to check whether it is equivalent to your searching element or not. First statement. So I am going to search a of mid equal to a of mid equal to key. So if the element is not found, then we need to search for one more element, a of array mid less than key. So I'm going to search for this. So whatever the element I had that is not equal to mid, so then I'm going to search a of mid less than your searching element 2. A of mid is what? 2. A of 2, that is 3. 3 less than 2, condition false. So it means what? We are going to have this 2 element up to this elements. Only left side of your array is consisting your elements. So now we are going to do the same iteration on your left side array. So what my left side array is consisting? This one, only 1 and 2. This is the representation I had. So this is 0 and it 1, and my mid value will be 0 plus 1 by 2 equals to 0. So now what will happen? So my first element will be represented here. 0 by 2 is 0. So this is my representation. So is it your searching element? It means what? A of mid equal to x. So it is condition false. Why? Because a of mid is 1, equal to 2, condition false. So what we need to do? Again we need to consider for right side element. Why? Because 2 is greater than 1. So next condition is a of mid less than here 2. So a of mid is what? 1. 1 less than 2, condition true. So 2 is greater than 1. So then what we need to do? We need to consider only a right side array. So what your right side array is consisting? So mid plus 1 to j. So we are having only one element, that is 2. Again the iteration will be happen. Why? Because y less than or equals to j. So then we are going to look, the middle value is 0, 2 equal to 2, condition true. So after this we are having a break statement. So our condition will be stopped. So this is this logic we had for your iterative representations of your binary search. And here we have one more constraint. If when you are exceeding, whether your element is not found, so automatically either your j value will be decremented or your low value will be incremented. In such particular scenario, so your element is going to be represented as not found. So this is the representation we have for your binary search. So this is a mechanism we are going to use. It is an iterative technique and the easiest one. So we'll try to see the same logic for your recursive approach. So I'm just discussing that logic, how it is exactly it is going to work. So as given, there is one simple example I was taken. So simple I'm going to take. This is a representation I had. So now I am having the elements as 12, 13 and 21 and 36 and 40. Now we are having this kind of strategy. So these index positions are represented like this. Now see this. What this recursive statements are saying that. So first high greater than low, right? High greater than low. So what it is saying that your high value is greater than low. That's condition is always true. So then we need to find the mid value like low plus high by 2. So then we will find the mid position. And next, when you are coming out from the if, there is one more if statement, whether we need to check some constraints, whether a of mid is equivalent to your searching element or not. If it is true, we are going to return the mid value. If not, we are going to check one more condition, whether your a of mid is greater than m. So for example, 5 greater than m. It means what? So your searching element could be smaller than your 5. So we need to fall to left side. So your searching will be happen to one side. If not, else we are going to have one more part, binary search, and that is saying that we are going to increment your position by 1 and we are looking to right side. So either left side or right side. Only one off portion will be considered for your searching strategy. Other side will not be considered. So this is the logic we had. So then we'll try to apply this on your array. So first I was taken some kind of array and I'm accepting some values. I was printed the values. Then I'm identifying that how many elements are there by using this mechanism as we discussed earlier. So next percentile d of m. So this will do what? It will accept some kind of value which you are searching for. For example, I'm searching for 12. I'm searching for element 12. So then next I'm going to find whether the result is identified or not. So for this I am using a function binary search. I am passing an array. Starting index position is 0 and last index position is n minus 1. So I am having 10 elements. 10 minus 1, 9. So because index position is up to 9, so then m is for your searching element. So when you are doing a function call, so automatically what will happen? I need to do some recursive representation. So just try to assume like this. I'm having main. From the main, I'm calling one more function. The function name is bs. Now bs is start executing. So this function is started doing execution. I am going here, and now I am having some kind of strategy. So high is less than low. So high is greater than or equal to low. Condition is true. Why? Because high is 4 and greater than or equals to 0. It is always true. So next, if it is true, I am going to find the mid value. The mid is nothing but low plus high by 2. So then 4 by 2 is equivalent to 2. My index position will be 2. So after this, your searching element is here. So next, what should I do? I need to look for a of mid, that is 21 is equivalent to my searching element. My searching element is what? 12 as per our discussion. So 21 is equivalent to equal to 12, condition false. So I'm going to look for next condition, a of mid greater than m. So that is a of mid value is what? 21. Is it greater than m? 21 is greater than m 12. Is that true? Yes, this condition is true. It means what? We need to look for an element for your left side array. We are not going to look for right side array. So this is a representation we had. So now from this what we need to do? 21 less than 2. This condition is true. So now I am going to return a function call. I'm going to return a function call. No need to execute else part, only execution of this. So if you are going to do a function call, what will happen? Again the memory will be allocated. So the memory will be allocated for your next bs function. This bx is containing array. The array is from where? From a low comma mid minus 1. So from this array we are going to consider from 0 to mid minus 1. Mid minus 1 is 1. So I am going to consider only two elements, 12 and 13. Next, this is my low value, that is 0. High value is 1. So now again check if condition is I greater than or